NASA's most dangerous rescue mission. NASA prepared Space Shuttle Endeavour for a quick launch on need rescue, which involved a complicated shuttle-to-shuttle rendezvous and spacewalk transfer of astronauts from Atlantis to Endeavour, guaranteeing their safe return to Earth. STS-400 was a special and extremely dangerous NASA contingency mission designed to rescue the crew of Space Shuttle Atlantis in the event that it had been damaged during the final Hubble Space Telescope servicing mission STS-125. This was because Atlantis orbited at a different inclination than the ISS, so the typical safe haven option was not available. Number 7. STS-400 Rescue Mission Preparedness. In order to save the crew of Space Shuttle Atlantis on its STS-125 servicing mission to the Hubble Space Telescope, a special backup mission known as STS-400 was prepared. There was no safe refuge for the crew in case Atlantis was wrecked, because the ISS orbit could not reach Hubble's orbit, 28.5 degrees inclination. Within 3 days of call-up, and as soon as 7 days following the launch of Atlantis, NASA maintained Space Shuttle Endeavour fully fueled and prepared on Launch Pad 39B, with a dedicated 4-person crew trained for a quick launch. This preparedness included meticulous mission planning for rendezvous, crew transfer, and safe return, as well as pre-staging additional spacesuits, EVA tools, and rescue hardware onboard Endeavour. With a focus on quick turnaround and high operating tempo, the mission was scheduled to last roughly 8 days. Given the intricacy of the rescue effort and the seriousness of the risk, this level of planning was unparalleled. Number 6. Extreme risks of close shuttle rendezvous. Endeavour had to meet a disabled Atlantis in orbit for the rescue, first getting close to roughly 35 feet about 23 meters away, and then using Endeavour's 50-foot robotic arm to grapple with a fixture on the cargo bay of Atlantis, close to the airlock. The two shuttles would subsequently be drawn into a parallel nose-to-tail position about 3 feet apart by the RMS's 90-degree rotation, a maneuver that would need extreme precision to prevent collision. To move crew and equipment, astronauts would perform several EVAs over the course of 2 to 3 days while attached to Kevlar ropes that were strung between the airlocks. Being linked between two orbiters in microgravity while traveling in heavy EMU spacesuits, the transfer was hazardous and physically taxing. There was always a chance of mechanical failure, suit punctures, or debris. Following handover, ground control would remotely direct Atlantis to deorbit and safely fall into the Pacific Ocean north of Hawaii, guaranteeing that no populated areas would be at risk. This intricate rendezvous and transfer operation, which combined difficult orbital mechanics problems with risky EVA operations, was unheard of in NASA history. Number 5. No safe haven at ISS for Hubble missions. Because of the Hubble's orbit's 28.5-degree inclination, which is far different from the ISS's 51.6-degree orbit, the ISS cannot be reached for rescue or shelter, unlike shuttle trips to the International Space Station, where crew might seek shelter for months if necessary. Due to the orbital geometry, there was a short window for rescue in the event that Atlantis was destroyed, because the crew would not be able to reach the ISS and would only have a limited supply of life support consumables on board. NASA was compelled to create the Shuttle-to-Shuttle Rescue Plan, or STS-400, as the only practical way to save the crew because there was no safe harbor. Because the rescue shuttle had to launch quickly and complete flawless rendezvous and transfer procedures in a matter of days, the time-sensitive nature of the mission increased its urgency and complexity. Number 4. Historical precedent: Columbia disaster and rescue planning. All 7 crew members tragically perished in the 2003 Space Shuttle Columbia accident, which was brought on by foam insulation colliding with the shuttle's thermal protection system during ascent. The risk of shuttle missions without a rescue option was made clear by this incident. NASA responded by implementing a launch-on-need rescue policy for shuttle missions to the International Space Station ISS, allowing personnel to spend months inside the station awaiting rescue. However, because of orbital discrepancies, this guideline did not apply to Hubble missions. NASA's response to this issue was the STS-400, a very intricate and dangerous rescue strategy designed to save crew without the possibility of taking refuge on the IS. The Columbia disaster had a significant impact on NASA's strategy, which led to the elaborate planning and backup plans that were incorporated on STS-400. Number 3. Technical challenges in satellite rescue attempts. The challenge of manual operations in microgravity was shown by earlier satellite recovery attempts, such as the 1984 Palapa B-2 satellite retrieval employing the Manned Maneuvering Unit. The sun's brightness made it difficult for astronauts to see, stabilize tumbling satellites, and regulate their own movements while handling big, recalcitrant items. The difficulty of spacewalks, including delicate manual operations, was brought to light by these missions. Because astronauts would be tied together and transferring between two orbiters in close proximity while handling heavy EMUs and delicate equipment, the STS-400 mission demanded considerably more precision. The mission's risk was increased by the possibility of suit punctures, tether failures, or mechanical issues during the multi-day transfer. Number 2. Soviet Salyut 7 rescue mission as a parallel. Cosmonauts manually piloted their Soyuz spacecraft to dock with a non-responsive station in 1985 as part of the Soviet Union's rescue of the failing Salyut 7 space station. They then carried out risky EVAs to restore power and systems, risky spacewalks to fix vital systems, manual docking in unpredictable conditions, and exceptional flying expertise were all necessary for this mission. It acts as a historical analogy that highlights the grave risks associated with space rescue operations. It demonstrated the courage and technical know-how needed for such missions by involving manual procedures, a high-risk rendezvous, and potentially fatal conditions, just like STS-400. Number 1. NASA's contingency and safety protocols. The STS-400 mission plan was meticulously choreographed with detailed timelines and procedures. Launch. Endeavour would launch with a crew of 4 astronauts within 3 days of call-up. Rendezvous. On Flight Day 2, Endeavour would rendezvous with Atlantis and grapple it using the RMS robotic arm. First, EVA. In order to transport a large EMU spacesuit and tie a Kevlar tether between the airlocks of the 2 shuttles, astronauts John Grunsfeld, Andrew Fustel, and Megan MacArthur would do the first EVA. Her EMU would be sent back to Atlantis after MacArthur repressed Endeavour. Subsequent EVAs. The remaining crew and equipment would be transferred by several EVAs on the 3rd day of the flight. After helping Gregory Johnson and Michael Massimino move an EMU to Atlantis, Grunsfeld would help Johnson repressurize Endeavour, while Massimino went back to Atlantis to get Scott Altman and Michael Good. The remaining crew and equipment would be transferred in the last EVA, which would take roughly 2.5 hours. Damaged shuttle disposal. After crew transfer, Atlantis would be remotely commanded to deorbit and crash safely in the Pacific Ocean north of Hawaii. Inspection and return. Endeavour would return to Earth on Flight Day 8 after performing a thorough heat shield inspection on Flight Day 5 to guarantee a safe re-entry. These topics highlight the personal bravery, technical complexity, and high stakes associated with planning NASA's most risky rescue mission. If you liked our video, please hit the like button and subscribe to our YouTube channel.